Hello, in this lecture we'll find out the radius of the circle. In the drawing we have a big semicircle. Inside this big semicircle we have two small semicircles and one circle. We know that this line segment equals to 140 units and this line segment equals to 70 units, and our mission is to find out the radius of this circle. Okay, so first of all we will define the points of those circles, circle and semicircles. The touching point between this semicircle and the biggest semicircle will be defined as A. The center of this semicircle will be defined as B. The center of the biggest semicircle will be defined as O. The touching point between those two semicircles will be defined as D. The center of the smallest semicircle, will be defined as E. The touching point between the smallest semicircle and the biggest semicircle will be defined as F. The touching point between this semicircle and this circle will be defined as a G. The touching point between this semicircle and this circle will be defined as H. The center of this circle will be defined as F, and the touching point between this circle and the biggest semicircle, this point will be defined as I. Here, this point is F, so we'll define the center of this semicircle as M. We know that line segment AF, it is the radius of the biggest semicircle. It is the diameter of the biggest semicircle. Okay? AF is the diameter of the biggest semicircle. I write it down. And the diameter of any circle or semicircle is twice as large or twice as long as the radius. So we will define the radius of the biggest semicircle as capital R. The radius of the biggest semicircle will be defined as capital R. And therefore AF, the diameter, will be equal to 2 times capital R. And according to what is given as the question, the diameter AF of the biggest semicircle equals to 140. This is 140 and this is 70. So the diameter of the biggest semicircle equals to AO plus OF. AO equals to 140 and OF equals to 70. Actually here AD, here it is AD plus DF, AD plus DF equals to AF. AF equals to AD plus DF. According to what is given in the question, AD equals to 140 units and DF equals to 70 units. So in conclusion, we found out that the diameter of the biggest semicircle equals to 140 plus 70, that is 210 units. So 2R equals to 210. Here we divide this equation by 2 and we get that R equals to 105 units. Okay, the radius of the biggest semicircle equals to 105 units. Because of the fact that the center of the biggest semicircle is at this point, point O, therefore AO is the radius of the biggest semicircle that is equal to 105 units. Why? Because it starts, line segment AO starts from the center of the biggest semicircle and ends at point on the biggest semicircle itself. Therefore, this is exactly the definition of a radius. Likewise, OF, line segment OF, is also the radius of the biggest circle, the biggest semicircle. Why? Because it starts from the center of the biggest semicircle, that is to say from point O, and ends at point F, that is a point on the biggest semicircle itself. So OF is the radius of the biggest semicircle that is also equals to 105 units. Okay? And actually, it is given us the question that AD equals to 140 units. Okay? But what is AD? AD is the diameter of this semicircle. And because of the fact that the diameter of this semicircle equals to 140 units, it means that the radius must be equal to half of it. That is to say, the radius must be equal to 140 over 2, that is 70. So here, AB is the radius of this semicircle that is equal to 70 units. Why? Because point B is the center of the semicircle and point A is the point on the semicircle itself. This is exactly the definition of a radius. Therefore, AB, that is the radius of this semicircle, it is equal to 70 units. Likewise, BD it is also the radius of this semicircle that is also equals to 70 units. Again, point B is the center of this semicircle, point B is the center of this semicircle, point D is the point on this semicircle itself, therefore BD is the radius of this semicircle that is equal to 70 units. Likewise, it is given us the question that line segment DF equals to 70 units. Okay, is equal to 70 units. That is to say, the diameter of the smallest semicircle equals to 70 units. Therefore, the radius must be equal to half of it. That is to say, the radius must be equal to 70 over 2. That is 35 units. So DE, that is the radius of the smallest semicircle, equals to 35 units, and EF, that is also the radius of the smallest semicircle, it is equal to 35 units. So repeat again that point E is the center of the smallest semicircle, point F is a point on the smallest semicircle itself, therefore EF is the radius of this semicircle that is equal to 35 units. Okay, and what is the length of line segment BO? O is the center of the biggest semicircle. Okay, so here BO, hold Robin, it is very easy to see that BO equals to AO minus AB. Again, BO equals to AO minus AB. AO minus AB equals to BO. So I write it down. Line segment BO equals to AO minus AB. Okay, BO equals to AO minus AB. Repeat again. BO equals to AO minus AB. So BO equals to AO. What is line segment AO? Point O is the center of the biggest semicircle, and point A is the point on the biggest semicircle itself. This is exactly the definition of a radius. So here AO is even what it's here, that AO equals to 105 units. It is the radius of the biggest semicircle minus AB. Here AB equals to 70 units. So in conclusion, I found out that BO equals to AO minus AB. AO is 105 units, AB is 70 units. So BO equals to 105 minus 70 is 35. So BO, line segment BO equals to 35 units. Okay. BO equals to 35 units. And what is the length of line segment DO? The length of line segment DO, for a dovin, it is very easy to see that DO equals to OF minus DF. Again, OF minus DF equals to OD or DO. So it is OF minus DF. Repeat again, the length of line segment DO is OF minus DF. So DO equals to OF. Here, I wrote it here that OF equals to 105 units. It is the radius of the biggest circle. So we substitute OF by 105 minus DF. It is given us in the question that DF equals to 70 units. So we substitute DF by 70. In conclusion, we found out that DO equals to 105 minus 70, that is 35 units. DO equals to 35 units. Here we can write down that DO equals to 35 units. Okay. In the next step, we will connect together by a straight line points B and M. Point B is the center of this semicircle, point M is the center of the circle. Actually, we are connecting together the two centers by a straight line. The semicircle and the circle have an external knot between them, at point G. That is to say, they are touching each other externally at point G. And we actually have rule number 11 that states that if two circles are touching each other externally, then the straight line that connects their centers together passes through their touching points. Here, the center of the big circle is point O, the center of the small circle is point M. The straight line that connects between the two centers together, OM and M. So the straight line OM, or line segment OM, passes through point N, that is their touching point. And in addition, we also know that the distance D between the two centers will be equal to capital R plus small r. OM equals to capital R plus small r. So D equals to capital R plus small r. So therefore, actually, line segment BM passes through point G, that is the touching point between the semicircle and the circle. So if we define the radius of the small circle as small r, so GM equals to small r, then BG will be the radius of this semicircle, and we know that the radius of this semicircle equals to 70 degrees. So BG equals to 70 degrees. In total, the distance between their centers, that is to say BM, equals to 70 plus R. Okay? In the next step, we will join the center of the smallest semicircle with the center of this circle. The distance between the two circles that have an external notch between them, like in this drawing, this circle have an external notch between the smallest semicircle. The distance between the centers, that is to say ME, will be equal to the radius of this circle plus the radius of the smallest semicircles. The radius of the circle is defined as r, small r, and we know that the radius of the smallest semicircle equals to 35 degrees, so it is 35 plus r. Okay. In the next step, we will join the center of the biggest semicircle, that is to say point O, with the center of the circle, that is at point M, and we will extend then the straight line until it touches the circle at point I. This is the touching point between the biggest semicircle and the circle. So we have actually here rule number 10 that deals with two circles that have an internal notch between them. That is to say, they are touching each other internally. Like in this drawing, the small semicircle is touching the big semicircle at point N. Point N is the touching point, and the touching point is they are touching each other internally. They are touching each other internally because the small circle is inside the big circle. So according to rule number 10, if two circles are touching each other internally, like in this drawing, then the straight line that connects their centers together, that is to say OM point M is the center of the small circle, point O is the center of the big circle, therefore OM or MO is the straight line that connects the two centers together. The centers are O and M. So this straight line OM must pass for their touching point, that is actually point N. Point N is the touching point between the big circle and the small circle. Okay? I repeat again, if two circles are touching each other internally, then the straight line that connects their centers together passes through their touching point. Their touching point is at point N. Okay, that is the point of tendency of their touching point. That is to say, the straight line OM must pass through point N. That is to say, OMN is one straight line. And what is the distance between the two centers? That is to say, OM, ED, that is equals to OM, it is equal to capital R, the radius of the big circle, that is capital R, minus the radius of the small circle, that is R. Okay, so I repeat again, if two circles are touching each other internally, then the straight line that connects their centers together must pass through their touching point, and the distance between their centers, that is to say D, that is equal to OM, equals to the radius of the big circle, that is capital R, minus the radius of the small circle, that is small r. D equals to capital R minus small r. Okay, so we can implement rule number 10 in our drawing. Why? Because in our drawing, this circle touches the biggest semicircle at point I internally, because of the fact that the small circle is inside the biggest semicircle. So therefore, the straight line that connects their centers together, that is to say, here, the center of the biggest semicircle is at this point, point O. The center of the circle is at point M. So this straight line OM must pass through their touching point. That is actually point I. Point I is the touching point between the circle and the biggest semicircle. So you can see in the drawing. So therefore, here OM, the straight line that connects their centers together, that is OM, must pass through point I. That is their touching point. Okay? And therefore, MI will be the radius of the small circle, that is small r. And OI, what is OI? O is the center of the biggest semicircle. I is the point of the biggest semicircle itself. So OI, this is exactly the definition of a radius. OI is the radius of the biggest semicircle. So if we subtract the radius of the semicircle minus the radius of the small circle, that is to say capital R minus small r, this will be the distance between their centers, that is to say that will be equal to OM. OM is the distance between their centers, and it will be equal to capital R minus small r. Capital R equals to 105 units, that is the radius of the biggest circle. Small r equals to small r, or the radius of the small circle equals to small r. So in total, OM equals to 105 units minus small r. Okay. In the next step, I will present to you a new rule that is actually Stewart's rule, and we will implement the Stewart's rule in our drawing. Okay. Actually, Stewart's rule is true in any triangle. Or Stewart's theorem. Theorem rule doesn't matter. Stewart's theorem. In any triangle, so the triangle that I will draw could be any triangle. Triangle ABC could be any triangle. This is triangle ABC. We know that the length of side AB is equal to A units. Side AC equals to B units in its length. And side BC equals to C units in its length. And we also have here AO. AO, line segment AO equals to D units in its length. We also know that line segment BO equals to M units in its length, and line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation will be true. That A squared times N plus B squared times M equals to C, we'll open brackets, C times D squared plus M times N. I'll repeat again, in any triangle, triangle ABC could be any triangle. We know that the length of side AB is A units, side BC equals to C units in its length, side AC equals to B units in its length, BO equals to M units, and ON equals to N units in its length. And we also know that line segment AO equals to D units in its length. Again, side BC equals to C units in its length. Then, in any triangle, the following equation will be true. That A squared times N plus B squared times M will be equal to C. C is the length of side BC, times D squared, D is the length of line segment AO, plus M times N. M is the length of line segment BO, and N is the length of line segment OC. So actually we can implement the Stewart's theorem in our original drawing, because in our original drawing we have a triangle MBE. This is triangle MBE, and we have line segment MO inside the triangle. We know all the lengths of the line segments here. The only missing variable here is the radius of this circle. This is the radius that is equal to small r. This is the radius that we are looking for. So by solving the Stewart's theorem, we'll find out the value of small r. Okay, so so first of all, I will copy the triangle and we'll implement the Stewart's theorem in our triangle MBE. Okay. This is triangle MBE. This is a copy from the original drawing. And we have 9/7 MO inside the triangle MBE. According to the Stewart's theorem, so first of all, the length of 9/7 BM is BG plus GM. That is to say, it is actually 70 plus R. BM equals to 70 plus R units. BE, side BE of triangle MBE equals to BO plus OE. BO equals to 35 units, OE equals to 70 units, 35 plus 70 is 105 units. So BE equals to 105 units. And ME, 9/7 ME equals to M edge plus edge E. M edge is small r, edge E is 35. So it is 35 plus r. 35 plus r. What is the length of MO? As you can see here, MO, it is equals to MI, that is the radius of the biggest circle, that is to say it is equal to 105 units, minus the radius of the small circle, that is small r. Okay? So it is the radius of the biggest circle minus the radius of the circle. That is to say it is 105 minus small r units. What is the length of BO? BO equals to 35 degrees, 35 units. OE equals to 35 plus 35 units, that is 70 units. Okay? So according to Stewart's theorem, BM square times OE, BM square is 70 plus R square times OE, that is 70 plus ME square times BO. ME is 35 plus R, therefore ME square is 35 plus R square times BO. BO is 35, and it is equal to BE times MO square. MO is 105 minus R, therefore MO square, it is 105 minus R square, plus BO times OE. BO is 35 times OE is 70. And BE, it is 105. And substitute BE by 105. Side BE equals to 105 units. So 70 plus R square times 70 plus 35 plus R square times 35 equals to BE is 105, so I substitute BE by 105. inside the brackets we have 105 minus r squared plus 35 times 70, all under the brackets. Okay, so in the next step we will define the number 35 as x. Okay, according to our definition, 35 equals to x, and we substitute in this equation, that is Stewart's theorem, Stewart's equation actually, we'll substitute 35 in this equation by x. So here we have 70 is 2 times 35, that is to say it is 2x plus r times 70. 70 is 2x. Plus 35 is x, so we substitute 35 by x, plus r square times 35. 35 is x, so we substitute 35 by x. It is equals to 105 is 35 times 3, that is to say it is 3x. Inside the brackets we have again 105 is 3x, we substitute 105 by 3x minus r squared plus 35 is x, 70 is 2x, so it is x times 2x all under the brackets. Okay, so here we will divide this equation by x. So here x will get cancelled. So what is left from this equation, that is the Stewart's equation, after we cancel x? We have here 2 times 2x plus r plus x plus r squared is equal to 3 inside the brackets we have 3x minus r squared plus x times x is 2x squared, all under the brackets. So that is what is left from Stewart's equation. Here we will open the brackets on both sides of the equation. Here I forgot to put, here we have actually this square, and here also I must put square. So here it is also 2x plus r squared. Okay, I just forgot to put the square here, so I add it now. So 2 times 2x plus r squared is 2x squared, that is 4x squared, plus r squared, plus 2 times 2x times r, plus x plus r squared is x squared, plus r squared, plus 2xr, and it is equal to 3. Inside the brackets we have 3x minus r squared is equal to 3x squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr plus 2x squared, all under the brackets. So here we have 2 times 4x squared is 8x squared plus 2 times r squared is 2r squared, and here we have 2 times 2xr is 4xr, and 4xr times 2 is 8xr, and it is equal to plus x squared plus r squared plus 2xr, and it is equal to, first of all, it is 3. Inside the brackets we have 9x squared plus 2x squared is 11x squared plus r squared minus 6xr. Okay, so in this side of the equation we have 8x squared plus x squared is 9x squared, 2r squared plus r squared is 3r squared, 8xr plus 2xr is 10xr, and it is equal, in the other side of this equation, Stewart's equation, we have 3 times 11x squared is 33x squared, 3 times r squared is 3r squared, so it is plus 3r squared, plus 3 times minus 6r, it is actually minus 18xr. So we'll subtract 9x squared from this equation, and we'll get that 33x squared minus 9x squared is 24x squared. We have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we will add 18xr to this equation. So here we have 8xr plus 18xr is 28xr. In conclusion, we found out that 28xr equals to 24x squared. Here we will divide this equation by x. X equals to 35 units. That is the reason that we can divide by x. Okay. It is a positive number. It is allowable to do this operation. So 20xr over x is 28r, and x squared over x is x. So it is equal, this expression in total equals to 24x. Here we substitute x by 35, and we get that 28r equals to 24, and x is 35, so we substitute x by 35. Here we will divide this equation by 7, and we will get 28 over 7 is 4, so in total this expression equals to 4r. In the other side of the equation we have 35 over 7 is 5, so in total this of the equation we have 24 times 5. So I actually found out that 4r equals to 24 times 5. Here we'll divide this equation by 4, and we get that 4 over 4 is r equals to 24 over 4 is 6, so in total this expression equals to 6 times 5. So r equals to 6 times 5, 6 times 5 is 30. So we found out that r equals to 30 units. So actually the answer to our question is that the radius of this circle is equal to r, small r equals to 30 units. So in the next step, I will summarize the lecture. In the drawing, we have big semicircle. Inside this big semicircle, we have 2 small semicircles and 1 circle. And we also know that line segment AD equals to 140 units in its length, and line segment OF equals to 70 units in its length, and our mission is to find out the radius of this circle. Okay, so first of all, AF is the diameter of the biggest semicircle. Okay. Here AF is the diameter of the biggest semicircle. We know that the diameter of any circle or semicircle is twice as long as the radius. So R is the radius, capital R is the radius of the biggest semicircle, the radius of this biggest semicircle. AF is the diameter, and the diameter of the biggest semicircle, and the diameter of any semicircle or circle is twice as long as the radius. So OAF equals 2 times capital R. R is the radius of the biggest semicircle. So OAF equals to 2R, and according to what is given as the question, AF equals to AD, that is 140 units, plus OF, that is 70 units. Okay, so AF equals to AD plus DF, that is actually AD is 140 and DF is 70. 140 plus 70 is 210. So we found out that the diameter of the biggest semicircle AF equals to 210 units, and the diameter is twice as long as the radius. That is to say, the diameter that is 210 units equals to 2 times capital R, that is the radius of the biggest semicircle. Here we'll divide this equation by 2, and we'll find out that the radius of the biggest semicircle, capital R, equals to 105 units. Here, line segment AO starts from the center of the biggest semicircle, that is to say from point O, and ends at point A. Therefore, AO is the radius of the biggest semicircle, that is equal to 105 units. Line segment OF starts from the center of the biggest semicircle, that is to say from point O, and ends at point F, that is a point on the biggest semicircle itself. Therefore, this is exactly the definition of a radius. So OF is the radius of the biggest semicircle, that is equal to 105 units. Okay. Then here AD, from doing it is very easy to see that AD is equal to 140 units. It is the diameter of this semicircle. If the diameter is 140, it means that the radius is equal to half of it. So the radius of this semicircle AB is equal to 70 units, and BO, that is also the radius BD, that is also the radius of this semicircle, it is also equals to 35 units. Okay. Likewise, it is given us the question that BF, this is actually the diameter of this smallest semicircle, is equal to 70 units. Therefore, the radius must be equal to half of it. So the radius DE equals to 35 units, and the radius EF it is also equals to 35 units. Okay. And what is the length of line segment BO? BO equals to AO minus AB. From the drawing, it is very easy to see that BO equals to AO minus AB. Okay, BO equals to AO minus AB. AO is the radius of the biggest semicircle, that is equal to 105 units. AB is the radius of this semicircle, that is equal to 70 units. So in total, BO equals to 105 minus 70, this is 35 units. So here, line segment BO equals to 35 units. What is the length of this line segment DO? From the drawing, it is very easy to see that DO equals to OF minus DF. Again, OF minus DF equals to OD. Okay? OF minus DF equals to OD. Or DO equals to OF minus DF. OF is the radius of the biggest semicircle, that is 105 units. Here, DF is the diameter of this semicircle, that is equal to 70 units. Therefore, DO equals to 105 minus 70, that is 35 units. Line segment DO equals to 35 units. Okay? In the next step, actually presented to you two rules that are about two circles that are touching each other either internally or externally. According to rule number 10, if two circles are touching each other internally, that is to say, the small circle is inside the big circle and they are touching each other internally at point N. This is their touching point, or the point of tendency. Then the straight line that connects their centers together, the center of the small semicircle is at point M, the center of the big semicircle is at point O, and the straight line that connects the centers together is line segment MO. So this straight line segment OM must pass through their touching point. Their touching point is at point N. That is to say, OMN is one straight line. Okay? And what is the distance between their centers? That is actually MO. The distance MO equals to capital R minus small r. Capital R is the radius of the big circle, small r is the radius of the small circle. So capital R minus small r is equals to OM or MO, that is the distance between their centers. And if we have two circles that have an external arch between them, that is to say they are touching each other externally, like in this drawing, those two circles are touching each other externally at point N. So if two circles are touching each other externally, then the straight line that connects their centers together passes through their touching point. The center of the big circle is at point O. The center of the small circle is at point M. The straight line that connects their centers together is OM. So this straight line OM must pass from their touching point, that is actually point M. That is to say, O and M is one straight line. Okay? And what is the distance between their centers? That is actually D, that is equal to OM. OM equals to capital R plus small r. Capital R is the radius of the big circle, small r is the radius of the small circle. So the distance between their centers, that is to say OM, equals to capital R plus small r. So we actually implemented the two rules in our drawing. Why? Because in our drawing we have an external lunge between the biggest semicircle and this circle. That is to say, those two circle and semicircle are touching each other at point I. And therefore, the straight line that connects their centers together, that is to say OM, must pass for point I. That is to say, OMI is one straight line. Okay? Point O is the center of the biggest semicircle, point M is the center of the circle. So the straight line OM that connects their centers together must pass from their touching point, that is to say from point I. And what is the distance between their centers? According to what I've already showed to you, whenever you have an internal between two circles or semicircles, the distance between their centers will be equal to the radius of the big circle minus the radius of the small circle. In this case, it will be equal to capital R, that is the radius of the biggest semicircle, minus R, minus small r, that is the radius of the circle. Capital R equals to 105 units, small r equals to the radius of the small circle equals to small r, and therefore the distance between the centers will be 105 minus small r. So OM or MO equals to 105 minus small r. Okay. Likewise, we join the center of this semicircle with the center of the circle. And according to rule number 11, the center of the semicircle is point B, the center of the circle is point M. So the straight line that connects their centers together is BM. BM must pass through their touching point, that is to say from point G. That is to say BGM is one straight line. BGM is one straight line. And what is the distance between their centers? That is to say, what is the length of line segment BM? It will be equal to the radius of this circle, or the radius of this semicircle, plus the radius of this circle. The radius of this circle is small r, the radius of this circle is 70. Therefore, the distance between their centers, that is to say BM, equals to 70 plus r. Likewise, we joined the center of the smallest semicircle with the center of this circle. Those circle and semicircle have an external knot between them at point H. That is to say they are touching each other externally at point H. And whenever you have an external knot between two circles or semicircles, then the straight line that connects their centers together, EM, the straight line EM that connects their centers together must pass through their touching point, must pass through point H. And therefore, EH plus HM will be equal to EM. EH equals to 35 degrees, that is actually the radius of this semicircle. HM equals to small r, it is the radius of the circle. That is to say, the distance between their centers, EM equals to 35 plus r. Okay? And we also found out that line segment BO equals to 35 units, and line segment OE, from the drawing it is very easy to see, that line segment OE equals to 35 plus 35. Why? Because OD equals to 35 and DE equals to 35. Okay, that is to say OE equals to 70 units. Okay, so in the next step we'll implement Stewart's theorem in our drawing. So first of all, I'll present to you what is Stewart's theorem, and then we'll implement it on our drawing. So Stewart's theorem is true in any triangle. So here we have triangle ABC that could be any triangle. The length of side AB equals to A units, side AC equals to B units in its length, and side BC equals to C units in its length. AO equals to D units in its length. Line segment BO equals to N units, and line segment OC equals to N units in its length. And line segment BC of triangle ABC equals to C units in its length. Okay, then the following equation will be true, and this triangle ABC could be any triangle. A squared times n, A squared times n, plus B squared times m, B squared times m, equals to C is the length of side BC, times D squared, AO equals to D squared, plus m times n. Okay, I repeat again, according to the Stewart theorem, in any triangle, A squared times n plus B squared times n equals to C times D squared plus mn. Okay, we can actually implement Stewart's theorem in our drawing. Why? Because in our drawing we have triangle MBE. We know all the lengths of all the sides and line segments here, and we have line segment MO. We know that MO equals to 105 minus R units. So the only missing variable that we have here, when we will implement the Stewart's theorem in this triangle MBO, it is R, the radius of this circle, that is the radius that we are looking for. So by solving Stewart's theorem, or by implementing Stewart's theorem in our triangle MBE, we'll solve the equation, and we'll find out the value of R, that is the radius of this small circle, the radius that we are looking for. So this is actually triangle MBE that I copied from the original drawing. MB equals to 70 plus R units, ME equals to 35 plus R units. R is the radius of the small circle, the radius that we are looking for. BO equals to 35 units, OE equals to 70 units, and side B equals to 105 units. Okay, so we implemented here the Stewart's theorem, and according to Stewart's theorem, MB squared times OE, MB is 70 plus R, so its square is 70 plus R squared, times OE is 70, so we substitute OE by 70, plus ME squared times OB, ME is 35 plus R, so we substitute 35 plus R, we substitute ME by 35 plus R, and ME squared is 35 plus R squared, times OB. OB is 35, so we substitute OB by 35, and it must be equal to BE. BE is the length of side BE, that is actually 105 units, times MO squared. MO is 105 minus R, therefore MO squared is 105 minus R squared, plus BO times OE. BO is 35, OE is 70. Okay, so in conclusion, we found out that 70 plus R square times 70 plus 75 plus R square times 35 equals to BE times BE minus R square plus 35 times 70. BE equals to 105 units, therefore we substitute BE by 105. In conclusion, we found out that 70 plus R square times 70 plus 35 minus 35 plus R square times 35 equals to 105. In the brackets we have 105 minus R square plus 35 times 70, all under the brackets. Here we defined 35 as x, and we substituted all the 35s, all the multiplication of 35s by x. So here we have 70. 70 is 2 times 35, therefore it is 2x plus R square equals to times 70. Times 70 is times 2 times 35, that is 2x. Okay, it is times 2x. Here we have 2x plus 35 is x, so we substitute 35 by x plus R square plus 35, we substitute 35 by x. And it is equal to 105. 105 is 35 times 3, that is to say it is 35, it is 3 times x. Okay. In the brackets we have 105 again. 105 is 3 times 35, that is to say 3 times x minus R square plus x is 35, 70 is 2x. In total, this expression equals to x times 2x, all under the brackets. Here, we divided this equation by x, so here x will get cancelled, x will get cancelled, x will get cancelled. What is left of this equation after we cancelled x? Actually, we have here 2 times 2x plus R square plus x plus R square equals to 3 times 3x minus R square plus 2x square. 2x plus R square equals to 2x square, that is 4x square, plus R square plus 2 times 2xr, that is actually 4xr. So it is 2 times all inside the brackets plus x plus R square equals to x square plus R square plus 2 times xr. In the other side of the equation we have 3 times, inside the brackets we have 3x minus R square. 3x minus R square equals to 3x square, that is 9x square plus R square minus 2 times 3x times R, that is minus 6xr plus 2x square. So here we open the brackets, we have to multiply all this expression by 2. 2 times 4x square is 8x square. 2 times R square is 2R square. Inside the brackets we have 2 times 2xr, that is 4xr. 4xr times 2 is 8xr plus x square plus R square plus 2xr. Here we have x square plus R square plus 2xr. In the other side of the equation, we open the brackets. Before we open the brackets, inside the brackets we have 9x square plus 2x square is 11x square plus R square minus 6xr. So in this side of the equation we have 8x square plus x square is 9x square. 2r square plus r square is 3r square, and 8xr plus 2xr is 10xr. Here we open the brackets on the other side of the equation. 3 times 11x squared is 33x squared. Plus 3 times r squared is 3r squared. And 3 times minus 6r minus 6xr is minus 18xr. Okay, so we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we subtracted 9x squared from this equation. 33x squared minus 9x squared is 24x squared. Then we added 18xr to this equation. So here 8xr plus 18xr is 20xr. In conclusion, we found out that what is left from the equation is that 18xr equals to 24x squared. Here we divided this equation by x equals to 35, so it is not 0, therefore it is allowable to divide the equation by x. So we divided this equation by x. 28xr over x is 28r. 20x squared over x is 24x. So we found out that 28r equals to 24x. Now we substitute again x by 35. Okay, and we found out that 28r equals to 24x and x is 25, so it is 28r that is equal to 25 times 35. Here we divided this equation by 7 and we found out that 28 over 7 is 4, so in this side of the equation we have 4r, and 35 over 7 is 5. In this side of the equation we have 24 times 5. I repeat again. We found out that 4r equals to 24 times 5. Here we divided this equation by 4, and we got that 4r over 4 is r, and 24 over 4 is 6. So in total, in this side of the equation we have 6 times 5 is equal to r. 6 times 5 is 30. In conclusion, we found out that the radius of this circle that is inside the biggest circle, the biggest semicircle, the radius of this circle, small r, it is equal to 30 units. Okay, thank you very much.